Today we're going to move into exponents, specifically zero and negative exponents. We've already worked with positive exponents before, even with variables. Even though there's nothing written here, the exponent is 1, so x to the first, those are the same thing. If we had 2 squared, that really means 2 times 2, which is 4. Or if we had 2 to the third, that's 2 times 2 times 2, which is 8, and so on. So as we move into the negatives and also into 0 as an exponent, they each have their own property that we will use every time. When 0 is an exponent, we have for every non-zero number. Okay, so that means you can have positives, negatives, fractions, decimals, just anything except 0. What happens when that number has a 0 exponent, it actually becomes the number 1. This will make more sense when we get into the division with exponents. I'll explain to you why this is the way it is, but for now, just take it for face value. As we move into negative exponents, again, this is only for every non-zero number. And let's say we use b this time, and let's say b is to the negative second power. Okay, what this does with this negative power here, we know that any whole number, any letter, variable, whatever, if it doesn't have a denominator, then the denominator is always 1. So what we do with this negative exponent is we put the 1 up top, we put the b on the bottom, so it's like doing the reciprocal. Okay, so y'all remember the reciprocal. So it's like doing that, only now this exponent becomes 2 instead of a negative 2. Okay? The reverse of that, let's say it was 1 over x to the negative third. Now because it's negative in the bottom, we do the same concept. You want to use the reciprocal, and it becomes positive when you flip it. So this becomes x to the positive third, over 1, or just x to the third. Okay? So let's do some examples. We will start with only numbers first. The first thing you want to keep in mind when you are simplifying powers and expressions with numbers, variables, anything, you always want positive exponents. Okay? So you don't want to leave them as negatives ever. So for example, let's say I have 2 to the second times 3 to the negative 1. Okay, so what we have here, 2 to the second power has a positive exponent. So we just multiply that out. Remember that 2 to the second means 2 times 2. So we get 4. And then we'll just bring down the 3 to the negative first. Now remember the property, and I'll flip back for you, the property with the negative exponents is if it has a negative exponent, you move it to the bottom, it becomes positive. So when we do that for this number, 4 will stay on the top, up here, as it is, but we will flip this. Remember 3 is 3 over 1, so this becomes 1 over 3 to the first power. If a number has 1 as its, so if it has the number 1 as its exponent, you don't write that number. You don't write 1. Okay, so that's important to remember that 3 right here by itself is the same as 3 to the first power. Okay, now when we go to simplify this completely, remember when you multiply a fraction by a whole number, change that whole number to be over 1, and this becomes 4 over 3. So now we have completely transformed this expression to be the same as that right there. Simplified version, the expanded version. So let's go ahead and look at another example. If I had 2 times 4 squared times 5 to the 0 power. Now with this one, 2 has an exponent of 1, so this one, the exponent is 1. The exponent here is 2, and the exponent here is 0. According to our 0 exponent rule, this actually ends up becoming the number 1. So really what this expression becomes is 2 times 4 squared times 1. But writing this 1 isn't necessary because multiplying by 1 doesn't change anything. So now what we have is 2 times 4 squared. Remember that 4 squared means 4 times 4. 4 squared is not, so this means does not equal 4 times 2. Okay, that is not how it's done. So what we have here now is 2 times 4 times 4. We know that 4 times 4 is 16, so we have 2 times 16, and that would be 32. So again, this right here is the expanded version, and when we simplify it, we get just the number 32. I'm going to go ahead and skip over that one and move on to one that has numbers and variables in it. So let's say I have 3x squared y to the 0 power z to the negative 4. So there's a lot going on here. One thing that you have to remember is that each one of these numbers, so this 3, the variable x with the square, the variable y with the 0, and also z with the negative 4, these are all individual terms. They all have their own exponent. For example, this one, its exponent is 1. For x squared, its exponent is 2, and so on. Y has an exponent of 0, and z has the exponent of negative 4. The reason I say that is because when we go to simplify, this z is the only term in this whole expression that has a negative exponent, so this will be the only term to move places. This is the only one that will go. So 3 stays as it is because the exponent was 1, and 3 to the first power just means 3. X squared is already positive, so we leave x squared as it is. Remember the rule for the power of 0. Anything raised to the 0 power is 1. So this actually becomes 1. So we multiply by 1, and then we take our z to the negative 4. Remember, this really is like saying this is over 1. We do the reciprocal. So 1 over z, make the exponent positive. So we have this 1 over z to the 4th. And now when you go to combine everything, remember that the 3 is over 1, x squared is over 1, 1 is over 1. So we end up with, multiply the numerators straight across. So if we multiply all of these, we end up with our 3x squared, and that's it. And on the bottom, we multiply only our denominators, so remember it's just these numbers down here, so we end up with z to the 4th, and that would be all you would do to simplify from here to here. Okay, let's go ahead and look at another example. Let's say that this time we have two exponents that are negative, and let's say both are variables, so negative 1 and let's say b to the negative 6, and that's all that we have. Remember, before, any time that we would write an expression or an equation, if we just had x, that was exactly the same as saying that the coefficient, and that is the number in front of the variable, the coefficient is 1. Okay, so this really is the number 1 in front of this. So even though the 1 is not written in front of the a, it's there in your mind. You picture it to be there. So when we go to flip these, because they are negative exponents, we take this, put it over 1, we take this, put it over 1, and remember that if these two are attached in this manner, they are being multiplied. So we end up with the reciprocal, 1 over a. The exponent becomes positive, so remember that a is the same as a to the 1. Okay, those are the same thing, and we multiply by 1 over the reciprocal, b, and then positive 6. We combine them to simplify completely, and we get a times b to the 6th power. And here is our simplified version of our original problem. From here, you may see exams ask you to simplify and then to figure out what specific values would be if you plug them in. So to simplify and then evaluate. So for example, if I had 3s squared t to the negative 2nd, simplify first, evaluate after. Okay, so I will tell you, I would like you to do this with s is equal to the number 2 and t is equal to the number negative 3. We are doing this last. We are putting this in last. We are simplifying first. 3, the exponent 1 is 1, it stays. S squared, 2 is positive, we leave it. T, we have a negative power, so this goes over 1. We multiply by the reciprocal, and it becomes a positive exponent. From there, we combine. Remember that these are both over 1. So what we end up with in the simplified version is 3s squared over t squared. After you've done this, now you can evaluate the expression. So remember that evaluating is just plugging in the values that were given to you. And remember also when you do that to use parentheses. That's especially important with this negative 3. So we take our 3, in parentheses we put 2, the square goes on the outside because this part right here, s, is this part. Okay, the square is not part of the s, it's attached to the s. Now we put that over t, which is our negative 3. Remember that goes in parentheses, and the reason I say that is because if you write this, technically that is negative 1 times 3 squared, which is a negative 9. Okay, so make sure you put it in parentheses because it is entirely different than when you do not. So negative goes inside the parentheses with that 3. Now when we go to simplify this, we have 3, 2 squared is 4, so 3 times 4 up top. On the bottom, negative 3 squared, so negative 3 times negative 3 is a positive 9, so that goes over 9. So we end up with 12 over 9. Now these both have factors in common, so we're going to go ahead and simplify this fraction. I'm going to rewrite it over here so you have some more room to see. So I'm going to take that 12 over 9. We know that these are both divisible by 3. So we end up with 4 over 3. So there is our simplified version after we have evaluated using these values. So we started with this problem. We simplified here. So this was the simplified version. And then we evaluated, simplified, 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 answer. Okay, so a quick refresher. Take a look here. Anything with a 0 exponent is 1. Anything, so 3 to the 0 is 1. Negative x to the 0 1, it's all 1. And then as we move on into negative exponents, we have write them first as a fraction, put them over 1, and then do the reciprocal and make the exponent become positive.